Little Caesar?
I don't know. I'm trying to contact him, but he's not responding.
He's not responding in our secret segment. Like, what's the group do?
Everything is fine.
All right, so we'll call this guy Fall 2016 Shunting Yard. We'll make it for those devices. Start with an empty activity. We'll call the first guy main activity. It's like they've messed up their Start New Project wizard. Just have to restart the Android Studio in order to get it to work. All right, I think that's looking better now. So let's start off by giving ourselves our little text box to read in our string, right? And then we'll work on how we can display stuff. Because if you look here at the algorithm, we have kind of three different things we're working with, right? We have our input, output, and operator stack. So now this input, this guy's our string, right? The input string that we got. And what do we do with that? As we're building something up, we're building up a token. And as soon as we have that token, we either put it onto the operator stack or we put it onto the output stack. That make sense? Okay, but we have to build up the entire token.
Yeah.
So like if we had 123 plus 14, and I read in the 1. 1 is not an operator, so we're building up a token. So we read in the 1, then we read in the 2, then we read in the 3. Now we have a full token. We ignore spaces. We were wondering where you were, Little Caesar.
Yeah, I was kind of out of my head. So,
Out of your head?
yeah, the weather's been changing a lot, so I'm not really
Oh, so you've been sick.
kind
Yeah, I know the feeling. Last week sucked. Still recovering. All right, so let's go to our layout. Here's our main activity here. I'm going to dump the hello world thing. I'm going to go ahead and throw in a vertical linear layout to work with here. And then at the top of that, we'll go ahead and put in our input text box. So we need an edit text. All right. And we'll go ahead and center that guy. And we'll set this to enter math. Good enough. Change the text to be nothing. And we'll name this guy input ET. That's going to be our actual input. All right. I don't remember if I told you this last week, but notice there's a thing called hint. And if you use hint, what it does is it that helps the user know what you're supposed to type in, but as soon as they start typing, that goes away. So as opposed to them using text to put it in there. And then you also then don't have to use a label to label what this thing is for. All right, let's go ahead and give ourselves maybe a couple of buttons. One button for clearing the text box. Just a little extra practice working with hooking up buttons to the so in order to do that, I'm going to have those two buttons next to each other. So I'm going to probably do this in a horizontal linear layout. So the next thing I'll slap in here is a horizontal linear layout. And then I'll throw a couple of buttons into that guy. So there's one button. I think it actually landed on the wrong side, but since I haven't done anything with the buttons yet, it's fine. One button's just as good as any other button. So we'll call this guy the clear button. And we probably actually don't need access directly to the button, so but we'll name it anyways. Yeah, actually, let's just leave it. Might as well not waste your time naming things that you're not going to have to use directly. So we'll just leave it called button 2, but I am going to change the text to be clear. And we're going to change the text in this guy to maybe called process, something like that. Okay. And then ultimately, we're going to be outputting the answer in like maybe a label, a text field, text view, is that what it's called? So we'll toss that guy in there. So this guy, notice, is inside the vertical linear layout, but not inside the horizontal one. The horizontal one is holding my two buttons. Make sense? So through practice, you'll kind of get better at building these interfaces. I kind of take a pretty easy approach with the linear layouts and stuff like that, but it sometimes gets a little wonky. There's probably some situations when you were writing your applications where you wanted something to show up in a certain place and you just couldn't get it to go there. Sometimes it just doesn't behave. That just comes with practice. So I'm going to make this guy a little bit bigger text. So let's change the text size to 24. We'll go ahead and center it. We'll make it bold. Perfect. And we're going to give this guy a name, though. We'll call this guy Output TV for our text view. Okay. Now let's just go ahead and let's create a couple of, participate in MVC. We talked about what is MVC? Remind me about that.
Model View Controller.
Okay, and what does that mean? Fancy name for what? What's the purpose of MVC?
It's a design which we are using to build an application by separating the logic, user interface, and all that.
Okay, so the idea is it's helpful to have our code in one place, our user interface in another place. So the view is the user interface. Our logic is the C for the controller. And then the other guy, the guy that's called the model, we haven't really dealt with it yet, but that's actually kind of like data storage. That's our data. So we model our data in one place, we model our logic in another place, and we have our view in another place. And then we make sure those guys can talk to each other. All right, so let's get these dudes talking. So we want to give ourselves programmatic access to this edit text and programmatic access to this table view, or text view rather, inside of our main activity. So let's go over to, I'm lost. Oh, here we are. All right, so we'll come in here. So up top here, I'll go ahead and create a couple of private variables. So we're going to say private edit text input ET, and we'll have a private text view output TV. And then down here, we'll go ahead and grab those two guys, actually completing the connections. So we'll say this dot input ET is equal to the edit text version of this dot, and this is an activity, and activities know how to find a view by its ID, and we're going to use the built-in class that Android builds for us called R. dot ID dot input ET. Now, by default, this guy gives us a generic view, so we're converting that guy to an edit text. Make sense? So this dot output TV is equal to the text view version of this dot find view by ID r dot ID dot output TV. Okay. So now we have programmatic access to those two dudes. You want some fries?
No,
I'll sell them to you.
absolutely.
They were given to me. I wonder how much chewing the microphone is picking up. All right. Oh yeah, so in any case, you had mentioned, I had you look up the thing. So I guess last week in my delirium, I posted the same paper as the previous week. So we just won't have a paper this week. So.
I worked on, like, when I was working with Stack, I also came across queue data structure. So instead of not submitting it, I have worked on queues. A little bit interesting.
Okay. All right, so, well, that was weird. What the heck just happened? Great old project in sync. Okay. So I wrote a handler for my button. So when we click on that process button, we want this guy to get called. So I'm going to go ahead and connect that guy to the on-click event of our button in our layout. So that's for this process button. So I'll go down here to on-click. Click on that guy, and about half the time this works, half the time it doesn't. So we'll see if this is which half this is. Sometimes we have to go and paste the actual name of the function in there. I'm going to create another function here. Public void clear button pressed. And we'll just go ahead and this guy is going to take in the, he's going to say this dot input et dot set text to the empty string. That'll clear out that guy. So we'll go and hook that up. That's for this clear button. Go to the on click for it. There's our clear button pressed. We'll see if that holds up. All right, let's go ahead and launch this guy. Actually, here, let's just add one more thing just for testing. So we'll go ahead and say this dot input et dot set text to process clicked, just to give us confidence that these buttons are hooked up. So one of two things are going to happen right now. It's either going to work fine or it's going to crash. If it crashes, we'll go and change the on clicks to take the parentheses main activity out. It's very strange what how that's been working. So while this is launching, how long did you guys spend on the homework? How long did the project take you to write? 15 hours? So how many hours would you say total? 25 hours? Oh my gosh. How long did it take you?
Honestly,
You didn't even do it?
I tried. I ended up with the wrong algorithm.
Okay.
For the same, I mean, like for the second project, it happened the same. I ended up with the wrong algorithm. I created the list, then I tried to commit them. And this time also, I came with something wrong. The first time, I spent my 16 hours myself. Then I came to that guy for help and he helped me out. This time I was like, I couldn't drive, so I sent you a mail asking for 2 extension.
Was that today?
No, it was the day before.
You sent me an email? Man, I'm still catching up. All right. So, what was I doing? Oh, I launched this, didn't I?
Like when you get sick, you can't think on the right way.
Oh, I got, believe me, I get it.
I mean, like recently, I've been in Chicago last week. It's been 80, then it's coming down to 30 in the night, and again it's going on to 70. It's been doing that. But when I came to Wisconsin again on this Sunday, it was all cold. So I was
Catching up with the cold.
I don't know, it's getting warm, it's getting foggy, it's getting, I don't know where it's going. Last year was not this bad because I stayed at home all the time, but this time I got a car and I got around and got sick.
Let's take this so long. Well, everything thinks it's still cooking. Give it a second. I have low expectations for that particular launch. So let's try that again. Oh, so like, and now for next week, we have 2 options. So next week we have Thanksgiving break. We can either do the same thing we did last week, where I send you the videos, you can watch them on your own time and do the homework assignment, or we can try to meet on Monday instead of Wednesday. That means you'll have 2 less days to do your homework assignment, though. So I'm fine either way, whichever one you guys want to do. So if you want to think about it and huddle during one of the breaks and decide what you want, either way is fine. I have Wednesday available. We may not be able to meet in here if there's already a class in here, but we can find a room somewhere that we can meet in, or I can just send you the video to watch again.
Do you think I can get a deal on SSD this Thanksgiving?
Get a deal on a what?
SSD?
Oh, probably. I'm sure somebody has a good Black Friday deal.
I mean, the lowest price was like $30.
For what size? You want 1 terabyte?
Yeah,
I think you would get a good deal somewhere.
because eBay pretty much as many deals as I'm expecting. Like it's been like 250 and they went down to 230. It's not a big difference. I'm expecting like 180 something.
Okay.
Do you know some sites?
Well, I mean, you can, I usually, if you want the best deals, you might look at like Amazon and stuff like that for their, holiday specials, because they're going to, because of the bulk they can work with, they're going to be able to be the most aggressive.
Yes.
Similarly at Costco, I'm not sure if Costco sells solid state drives on their website, but, Costco has some crazy deals on TVs starting in 2 days. in 2 days. Like I'm going to be getting another TV in a couple of days. It's just ridiculous the deals they have. They have a 4K Samsung that's usually list price, let's say, is $1,500. It's like the Samsung's lowest end good 4K TV. No bells and whistles, but it's it's a good TV. It's not like a crap generic brand TV. Usually, I've seen this TV on sale for about $9.99. Best Buy had it on sale recently for $8.99. Starting on Friday through it's like a 2-week period or something like that. It's like $667 at for a 60-inch Samsung 4K TV.
Just the brand is like it's depreciating a lot.
Yeah, but they have all sorts of TVs are on sale. But that I have that TV already.
Oh, you have
I own that TV in my basement. It's I bought it for $8.99, then price adjusted it to the $667 because it would have been within my return. The 18th would have been within my return period. But I'm going to get a second one, so I like the TV a lot.
second one.
Well, I probably have a much bigger house than you do. Like you probably, I'm guessing I'm gonna visualize you live in like one room. You have like a single room that you live in,
I
or
got a 1 bedroom.
yeah, one bedroom. Okay, so you have a bedroom, a kitchen, and a bathroom. That's your place, right?
No, there are 2 halls,
Okay.
kitchen, a bedroom, and a bathroom.
Okay.
So
Yeah.
you live alone?
No, 2.
Yeah. So my place is a little
For us,
is a little.
it is like so difficult to live alone, and then there's we don't know.
Yeah, I got 3 people from the same college, but they are
Usually
from
people is
MSIs.
good for us.
Yeah, I've my place is a little bit bigger.
So you're gonna get that for your bedroom or
That one's gonna go. Well, we're going to be playing musical chairs. I think we're going to move our living room TV up to the guest bedroom. The guest bedroom TV down to be like a workstation thing I could hook up to computers that I'm fixing because that's kind of on the fritz, the ones in the guest bedroom. Because we have a big screen in bedroom, guest bedroom, living room, basement,
so basically
and garage.
you're buying it for me then. You don't got it in the room.
I have a big screen in my
But you can't
garage.
resist it, like, just get it and do it.
Like you don't have a big screen TV in your garage?
No, it's just 40 inches and it's not generic brand like Samsung and all. It's just 720p.
Mm-hmm. I gotcha.
It's good. When you see it from far. It's a lot.
Let's see if this makes things work a little bit better. Yeah, so I have a 65-inch in my garage hanging from the ceiling, so I can pivot
In
it.
your car garage?
Yeah, I don't keep cars in my garage though. In my garage, I have a hot tub, and I have my golf simulator. So my TV turns this way if I'm playing on my golf simulator, so I can watch TV. And I turn it the other way if I'm in the hot tub. I can watch TV from the hot tub.
So you're putting golf simulator on TV?
No, I have a computer out there. The simulator's on. I watch like Netflix on the TV.
I was expecting that you could watch it on the TV.
Yeah, I could have, but then I wouldn't be able to watch Netflix. It kind of defeats the purpose, right?
You use them all?
Mm-hmm.
You only got one, didn't you use it? So literally, maybe 1 or 2 hours in a month. Oh yeah. We just don't use it.
What do you do when you're home?
YouTube, games, assignments.
So you're on your computer most of the time.
Yeah, most of the time you're all on computer. No, I mean like all 3 people, 1 or 2 hours, not just one.
I gotcha. All right. Now let's see if this guy launches a little bit better. Yeah, I watch a lot of. So right now I'm watching while I'm playing. When I play video games, I watch Netflix. So down in my basement is where I have my computer room set up. So I have my 60-inch TV. Like I'd be sitting right here, the TV's like right here, but higher. So I can look at it like that while I'm playing. Yeah, while I'm playing my game, right now I'm working through all the old original Star Trek shows.
Oh, there are a lot of
Yeah,
them.
but the original Star Trek,
Not
is,
really, but if you get the whole collection, it's like 450 GB.
Oh, well, I'm streaming it on Netflix. All right, so let's type some crap in here. We'll clear it. Okay, yeah, we got the crash. So let's go fix it real quick. Click on that guy. Go to his on click. Come on. I have no idea. I have no idea. This is a pretty new feature. By feature, I mean a pretty new bug. Who knows? Forever, though, you've always had to just paste your name, your method in there. And I never had problems with it doing that. Now they try to make your life easier, but... All right, type some stuff in there, hit clear, process click, so our two buttons are working now. Okay, now we want to represent things. We're going to have three different stacks we're working with here, right? So just to kind of give us our, let's do a walkthrough of a sample shunting yard thing, just to make sure we're all on the same page and we understand how this guy works. Because at first, the shunting yard algorithm can be a little bit difficult to understand at first. It's not bad once you get into it, but let's go ahead and we're going to follow the rules for it. So we're going to give ourselves something like, let's do 12 plus 4 times.
7.
Yeah, let's just keep it simple like that. Keep it simple like that. All right, we'll throw parentheses in another example, but this is one that we can't just go left to right. Proper order of operation on this is going to be 4 times 7 plus 12, right? That's the correct order of operation. All right, so let's go back in here. Here's the shunting yard. Oh, here, we'll just look at it from this perspective. So A, B, these guys are our numbers, our values. So as we process that, anything that's a symbol, a number in our world, goes onto the output. Okay? So let's create our couple of stacks. So we're going to have output and we're going to have op. So here's output and there's op. And these are going to be stacks, so I'll just kind of build them to the right as we go. So a 12, we'll read in the 1, then we'll read in the 2. We built that up. We have 12 as that token. So we'll go ahead and we're going to push that onto the output stack, right? So there's our 12. All right. Now, we get to an operator. And what do we do with operators? Okay, operators go on to the op stack. All right, so we push that onto our op stack. All right, now we have our 4. And what do we do with our 4? We push it onto the output stack. So now the 4 is on top. All right, now we hit the multiplication. What do we do with that?
Multiplication has the higher precedency than...
Okay, so before we just haphazardly push this guy onto the stack, we're only allowed to push an operator onto the stack if that operator has a lower precedence. All right, so let's go back and review that. So when we, somewhere down here, they give you the list of precedences. Okay, here, if the token is an operator, while there is an operator at the top of the operator stack, and either the operator is left associative, we'll talk about that, the power symbols are actually right associative. If it's left associative and its precedence is less than or equal to the operator that we want to push on. Okay, so we have an operator O2. Let's see. No, we have an operator O1 that we want to push onto the stack. If O2, which is the operator already on the stack, has a precedence that is less than or greater than O1. So I have to reverse this guy here. So if O2 is the guy on the top of the stack, so this is O1, this is O2 in this example. All right, so O1 is our guy we want to add. Is he left associative? He is. Okay, he's not a power symbol. All right, so forget about the left associative thing for right now. Now we got to look at his precedence. So we will put him at the top of the operator stack if his precedence is less than or equal to the guy that's already on there. Okay? Now the precedence of the multiplication operator is not less than or equal to the precedence of the plus sign. The precedence of the multiplication operator is higher than the plus sign. And somewhere down here, I think they list precedence, don't they? Yep. So precedence of multiplication is 3. 3 is not less than or equal to 2. Okay? All right. So we're to the top of the stack, and either this is true, or forget about the right associative thing right now. So under either of those things, we'll pop O2 off the stack and put it onto the output queue, but that's not what we're doing right now. Then at the end of the iteration, we push O1 onto the operator stack. So since the thing that's currently on the operator stack is less than or equal to the guy we want to do, can we push the multiplication onto the op stack? Yeah.
According to Thomas of Hanoi, is the
Okay. What happens if I do that? So let's just play it out here, right? So I burn through that. The 7 goes on the top of the stack. Now we said a few minutes ago that the first thing that we should do is do 4 times 7. So as we start processing this stuff, we're going to pop things off our op stack, right? Okay? So we come back here. When there are no more tokens to read, while there's still something on the operator stack, the operator token on the top of the stack is a parenthesis, then we have to look for a match parenthesis, forget about that. Otherwise, pop the operator onto the output queue. So we need to clear our output queue right now. So we would, if we leave it like this, we'll pop that, and then we'll pop that. Make sense? Okay, that's if we put them on in this order. Okay, so now these guys are now clear. We don't have anything on the op stack. How do we process our output stack? Now we actually need to do the math. Well, I guess we'll just walk through it here then. All right, so I have a stack that looks like this. How do I do the math for this guy? I pop something off the stack. I'm looking at an operator. This guy says do addition, right? Okay. So addition requires 2 parameters, 2 inputs. The next guy I pop off is another operator. And that operator says do multiplication. which requires 2 parameters. There's my 7 and there's my 4. So 7 times 4 will be my first value, which will be the first parameter for the plus. Then I get to my 12. Make sense? So this is the correct order, is it not? As opposed to, let's flip these around. Well, here, let's do it the wrong way, and then we'll flip it around and see why it's wrong. So now we had our plus sign first. Then we decided, oh, well, maybe we can't push the multiplication on there. So what we'll do is we'll go ahead and we'll pop the plus sign off. Then we'll push the multiplication on. Okay? So then we hit the 7. Actually, hold on, I'm sorry, we're out of order actually. We're like that. Then we hit the 7. Now we're done with our inputs. Now we hit our multiplication. Now we're like that. So now as we go through here, we're going to multiply what? We're going to multiply 7 times 4 plus 12. That's not what we want. Correct? Okay, so what is the rule? Is if we already had the plus sign on there, we always put things on top of the plus sign as long as they are greater than the plus sign. If it's equal to, then the order of operation is left to right, so we would pop it. So if it's less than or equal to it, we pop the plus sign. Well, we actually keep popping until we have something that's not less than or equal to, right? Okay, so now if we flip these around, let's make this multiplication and let's make this addition. So we got our 12 output stack, we got our multiplication op stack, we got our 4 output stack, we got our addition. Now, addition, is that guy greater than multiplication?
No.
It's not. So we need to pop multiplication. Clearing this, is addition greater than nothing? Yeah, so we're allowed to put it on there, so we'll put the addition on there. Then we have our 7, and then we clear our op stack, so there's our plus. So what are we going to do now? We're going to add 7, but then we're going to multiply 4 times 12, giving us the answer there, and then we're going to add 7 to that. That give us the right order? Okay, so we kind of understand the rules for that guy? Okay. Let's initially write this with just that in mind. Just forget about parentheses for a few minutes. Forget about powers for a few minutes. Let's just get it working for multiplication, addition, those guys. So I'm going to go ahead and create a Java file in here for our shunting yard algorithm. So this would be our model if we're kind of connecting it to MVC. So I'm going to create an object for shunting yard that's built with a string, and that guy is going to process our string into its tokens, so on and so forth. All right, so I'm going to create a Java class. Call this guy shunting yard. And this guy will have a private input string of type string. Constructor for shunting yard. We'll take a string, input string as a parameter, and we'll set this dot input string equal to that input string. Then we'll have some private methods in here. So one of them should be to tokenize our string, right? So we want to split our string up on the individual tokens. So what are the acceptable tokens in our string? Acceptable tokens overall are going to be plus, minus, times, divide, power, open parenthesis, close parenthesis. Right? Anything else? That's all the ones the algorithm supported. We can support other things, we just have to make sure we know what the precedence is for those guys. All right? So we're going to go ahead and we're going to say private void process string. So by this guy being private, he's only accessible inside of this class called shunting yard. And the very first thing we're going to do is we need to split that string apart on those tokens. How did you do that?
We have a split method in the string.
Okay. So tell me how you would use the split method in string to split it up on like this. Do you split it on spaces?
You know, whenever you get an operator, you split it. First you take a number, and when you get an operator, you just push it on the other side.
I have a string that looks like that. And I want to turn that string into a collection that is 123.
Split won't work on this.
Can't you just compare it with plus minus into the previous step? If it is that, you can add it to the string.
So I don't care what this collection is, but I want to have, it could be an array of strings if you want. Okay, but I need a collection of those individual pieces in order to work through this.
You can put it on the linked list.
No, we have to process each character in the string.
I'm walking through this guy one character at a time.
One character.
How do I get this out of it? How did you guys do it?
I did it with the help of spaces and split method.
Okay, so your solution requires there to be spaces
Yes.
because you use the split function and you assume they're spaces, so you split all the pieces apart on spaces. Okay, fair enough.
I'm trying to just compare it with every operator I got, and if it matches with that, just keep it in the other stack and move on with the string.
Okay, so one thing we can do is we can start walking the string just normally, and as we're walking through here, we can be building up a string. So is this an operator? No. So add it to my current string I'm building. Is this an operator? No. Add it to the current string I'm building. Is this an operator? No. Add it to the current string I'm building. Is this an operator? Yes. So the current string I was building is a token. Go ahead and keep that. Then I keep the operator, skip past that. I'm going to go ahead and put a space over here just so you can see how that will work. Okay, so now I have the operator, I clear out my string, right? Is this an operator? Nope. Add to my current building string, which is currently empty. Is this an operator? Nope. Add to my current building string, which currently has a 1 on it. Is this an operator? No, but it's a space. What do we do with spaces? Ignore them. Okay, so we just keep going. We don't add it onto our current string we're building. We just work past it. Is this a operator? Yes. So 12 was our next thing. Clear it and then keep the multiplication. So now we've cleared out our string we're currently building. Is this an operator? No, it's a space. Ignore it. Space. Ignore it. Space. Ignore it. Is this an operator? No, it's not a space though. Let's keep it. So now we have a 7 in our string. Then we hit the end of the string. Right? So we can write an algorithm that does that. How many of you have seen something called the Stringtokenizer before? If you had 535 with me, I'm 99.9% positive I introduced it. So we're going to create something here called the Stringtokenizer. It's going to be a new Stringtokenizer. And we're going to build this out of this dot input string. And we're going to give it the
We have an assignment.
Yeah. So we're going to build it using that input string. Then we're going to give it a string representation of our tokens. So our tokens are plus, minus, times, divide, power, open, close parentheses. And then the last thing it takes is a Boolean value, true or false. True if you want the tokenizer to also return the delimiters. These are our delimiters, and false otherwise. These are important to us, right? So we want to say true there. Yes, give me the delimiters with it. What this guy will produce for us is an array of strings. It'll have 123. It'll have plus. Ultimately, we'll be able to build an array of strings out of this. It will have 12. Actually, it'll have a 12 space like that. It will have multiplication. It will have a space, space, space 7 like that. That will be the collection of tokens that comes down to. I ultimately want to massage that into that collection of tokens. So if I have something that looks like this, how can I turn it into something that looks like that? So this is an array of strings. How can I make that array of strings look like this array of strings? What do I have to do to it?
Trim this blank spaces.
You need to put it on the other stack or something. Remove the empty ones.
Let's keep it simple. How do I turn just that string into that string?
Read the first one. Then if it is space, then remove it.
How do I remove it?
Don't push it on the stack.
Stacks don't exist. This is just a string function. Here's a string. I want that string to not have spaces at the beginning or at the end of it.
Does Stringtokenizer support the trim function?
Well, Stringtokenizer gives me some strings. Tell me about this trim function that you're talking about.
Trim function basically databases we have seen, like,
Yep.
the left trim and the right trim in
Yep.
SQL Server.
Yep.
So if
The string class has a trim function.
Okay.
So we can tell a string to trim itself, and that will return a new string that is a string that is the original string with all the leading spaces and all the trailing spaces removed. Okay, so if we knew about that, and it does exist, if we knew that existed, we could use that. What if we didn't know it existed? What if I wanted to write a method here?
Then we need to take it of substring.
So private string remove, let's call it extra spaces, because it's just going to remove them from the beginning and end. This guy will take a string as a parameter. So he should take this guy as a parameter and return a new string that is the original with all the spaces removed, with all the beginning and trailing spaces removed, not spaces in the middle. So if this was the string that, it would produce that.
Yeah.
Trim would produce that. It would not take the space between the sevens out. So trim removes the beginning spaces and removes the end spaces.
Yeah. We can take help of a loop and once again travel through all the characters one after the other. Ignore the spaces. Consider the
How many characters are in S?
S dot length.
Yep, S dot length number of characters. And each saying, since it's a string, we can't change strings, so we're going to have to build a new string, right?
Yeah.
So start that guy off as the empty string.
Result plus equal to.
Well, don't we need to find out if we're working with spaces or not?
Yeah.
We have to ask a question first, right?
If yeah.
So if what's true?
If the first character in the string is a space, like if s dot substring or s of in brackets if it supports the 0 character the array.
Okay, so you want bucket 0.
Yeah.
So that's s dot char at 0. That gives us bucket 0.
Yeah. Dot equals.
Okay, that guy's a char, so we would just use the primitive equivalence operator.
Equals in Java doesn't work actually. Dot equals method will help us.
I've been doing this for a few minutes, trust me.
Okay.
This guy is a char, not a string.
Character, yeah.
Yeah. If I want to compare a string to another string, I would say s dot equals
Okay.
blah or something like that. Okay, but this guy, s dot char at 0, is going to give me, in this case, that char. So these are char primitive types. And to compare char primitive types, we use the primitive equivalence operator. Yep, that makes sense? It's actually an important concept because it's easy to look at this and assume we're looking at a string because we used a string to get this char. But at the end of the day, once we got the costume off, that guy's a char. Make sense? Well, good. I'm glad. I like that. I mean, you were wrong, but I like that you were thinking about the details of it, not just taking whatever I say for granted. It's good. So you should be more like him.
I can't tell. You've seen me talking.
You sure you don't want these fries? I'm not gonna be able to eat them.
I'm like conscious. There's a lot of oil in it.
Okay, keep going. So I'm checking bucket 0. What if I have 5 spaces at the beginning?
The loop will iterate. You can replace this 0 with I.
Can't we just be like st of I is equal to the
Well, what are we trying to ask here?
if there is a space, if there is, you can just eliminate it.
If I have a string that looks like that, this guy in result should produce the string that. That's what my output should be. So when all is said and done, result should equal this if S was that. So I need to find the occurrence of the first non-space in my string. And I want everything from that point on in my string. And then I want to walk my string from the end back until I hit the first non-space. And keep only the stuff from there. Because I want to not touch anything in the middle there. So how do I find the location of the first thing in my string, the index of the first thing in my string that is not a space? Let's just solve that one little piece of the problem. I want to find the position of this 7. So that 7 is not at bucket 0. It's not at bucket 1. It's at bucket 2. I want to find that 2, the position of the first non-space. We'll call that guy pause 1. So all I'm looking for is the position of the first non-space. How do I find that? Okay, okay, so this is my dude that goes through the string, right? So each time through, we're going to say if s dot char at the current position I, if that guy is not equal to a space, that means that we have found the position of something. So we'll say pos1 is equal to I, and then let's break out of the loop. Make sense? So when this for loop is done, we know that pos1 is either equal to -1, which means we never found something that wasn't a space in there, or it's equal to the position of the first space. Okay? If it's a -1, that means that what they passed us was the empty string. Oh, well, what they passed us was, I guess, not necessarily the empty string. But it didn't have any non-space characters in it. All right, so now I want to find pos2. This guy will also, let's start this guy off the end of the string. So that'll be s.length. So that's one past the last legal position in our string. Okay, so I'm going to have another loop, and this loop's job is to figure out the position of the last character in the string that's not a space. So we'll start at the end of the string. So this is s.length -1, -2, -3. I want the position that's second 7. All right, so I'm going to write a loop that's going to go through my string backwards. So for int I is equal to s.length -1. Keep going as long as I is greater than or equal to 0. Subtract 1 from I each time. If s.char at I is not equal to a space, pos2 is equal to I, break. Make sense? Now, if, here, let me throw this in a comment so it doesn't give us errors. So now I have the position pos1 where the first non-space lives, the position pos2 where the last non-space lives. I want to keep everything between those. But I need to look at pos1 and pos2 a little bit carefully before I just make a decision, right? Because I need to look at them and say, you know what? If pos1 is still -1, that means that nothing in my string was something other than spaces. That means I never found something that wasn't a space. That makes sense? So if pos1 is -1, can't I just return the empty string? If I have a string with 10 spaces in it, the trim of that is actually the empty string. We've trimmed all leading and trailing spaces, right? So that's what we do if pos1 is -1. So we can actually do that immediately following this guy. We could say if pos1 is equal to -1, go ahead and return the empty string. That's my answer. The trimmed version of this string, no matter how many spaces was in it, is the empty string. Because I found no non-spaces in there. Make sense? So that means if I'm still kicking right here, because return makes a method immediately end. If I'm still alive, if I'm still kicking right here, that means I know I have a character in that string. I have a non-space in that string. I know that pos1 is a real value. Make sense? So now I have the position pos1, and I have the position 1 off the end. Okay? So if pos2 is still equal to the length of the string, that means that I know that I had no trailing spaces. So I want everything from pos1 all the way to the end. Right? So the last position I want is actually pos2 -1. That's the last guy I actually want. Make sense? Well, here, so let's say the length of our string is 5, and let's say pos2 is actually 3, which means that bucket 4 was a space. Okay? So we can say that we want everything up to and including pos2, or we could say we want everything up to but not including pos2. So we just have to decide how we want to treat pos2. Do I start pos 2 being 1 off the end of the string, or do I start pos 2 being at the end of the string? If I started at the last legal position in my string, I can take pos 2. So let's say we had the string that looked like this. So this is what? 0, 1, 2, 3, 4, 5, 6. 6 total buckets. So if I have it, this would be bucket 5. Right now, pos 2 is equal to a 5. So I'm going to check from 5, 4, 3. That guy has a value in it. This is the position of my last value. It's at 3. I want to keep everything from bucket 2. Actually, this is 0, 1, 2, 3, 4. That's 4. Oh, I counted wrong. So this is actually bucket 6, bucket 5, bucket 4. Okay, so I want to keep everything from 2 to 4. So pos 1 in that case was 2. Pos 2 was 4. Okay, the end of the zone we wanted to keep stuff from. All right. How do I keep stuff just in that range? So pos 1 and pos 2 that's our range. And the pos 2 gives us the position of the last guy, including that position. If pos 2 is 4, that means I also want the thing at bucket 4. Does that make sense? Okay. Which means that it probably is in our best interest to start pos 2 off at a legal position. Because if we keep it at that, we want to actually grab everything up to the end of the string. Make sense? So we said s.length minus 1 here, but we could have just as easily said pos 2. Those are synonyms. But, yeah, actually, it won't hurt anything, but we'll leave it like that. We want to start at the end of the string, and we want to find the position of the last character, the last non-space. All right? So pos 2 will be that position. If pos 2 never gets changed, we know that it's all the way to the end of the string. Okay? So after this guy is done, we need to now build our new string. So for int I is equal to 0, is equal to pos 1, I is less than or equal to pos 2, I plus plus, result plus equals s dot char add I. Return result. That make sense? So that's an algorithm for trimming the spaces from the beginning of a string to the end of and off the end of the string. It's a lot of work, isn't it?
Yeah, yes.
So
Central,
say this again.
the central space,
We don't do anything to it. The trim does not take anything away from the center space. If we wanted to just remove all spaces, this would have been a lot easier. Remove spaces is trivial compared to this. Private string remove spaces takes a string s as a parameter. We have string result is equal to the empty string for int I is equal to 0. I is less than s dot length I plus plus. If s dot char at I is not equal to a space, keep it. Ooh. That's it. So that's return spaces or remove spaces. Well, because the other thing is correct. Because we know the nature of our data, in our case, since our numbers will never have spaces in them, we could just say remove spaces. But generically, trim says remove everything before the first character or remove everything after the last character. Trim the ends. That make sense? But this gives us an appreciation for the complexity of that algorithm for trimming, right? For us, rather than doing all that, we would probably just choose to say s dot trim. Trim the string. The output of s dot trim will be the same as the output of the function we just wrote. Okay, so what we have here inside of our tokenizer is a collection of tokens. And we want to go ahead and add that collection of tokens into our input list, our input queue. Okay? So what I'm going to do is, let's just create this guy as an array list of string. Have you guys done array list before?
Arrays, we are
No, not arrays. There's, okay, so forget about it. So I'm going to say private string array. We'll call this inputs. And then down here, after we create our tokenizer, we'll go ahead and say this dot inputs is equal to a new string array. And we want that string array to have enough spaces in it to hold all of the tokens. All right, so we're going to say st.count tokens. That'll give us the number of tokens that it found, including the delimiters themselves, because that we use the true there. All right, let me show you real quick in the documentation. Java string tokenizer. And you didn't have to use this. You could have done it, by parsing it yourself. Constructors. Yeah, this one right here. So string tokenizer, here's the string we're tokenizing. Here's the delimiters we're tokenizing it on. And whether we want it to return the delimiters as tokens. Or the default is to not return them as tokens. So we're using this constructor right here. Make sense? So now our array is big enough to hold all those guys. So I'll say while st dot has more tokens, we'll say we can do it. We'll say this dot inputs at bucket pause is equal to st dot next token, which comes out as a string. And then we'll say pause plus plus. Technically, we could have said pause plus plus right there, and it would have been correct. I do not encourage that syntax because, so do all of you know what that means when I say pause plus plus in line there? Because we want pause to be one bigger than it used to be. So could I have also done that? Same thing? How's it different?
in this case, it will increment the position and returns the token in the next space. In the previous case, it will first return the token on the existing position.
Okay.
Moves to the next position.
Okay. Are you confident?
That's what I think.
Okay. What do you think?
Same thing.
What he said? Do you agree with him? Are you confident?
Yeah, I'm confident.
Willing to bet your grade on it?
25%, 10%.
What about you?
No,
I mean, increment and post increment thing goes.
not increment first. We are saying certain thing and the next state is incrementing the next position, so it is not even say.
So you're not sure.
Increment the position.
So it's not, so bottom line is you're not really sure. You're not confident,
No.
right? Okay. So he's right. He got the right answer, but he didn't come off as being all that confident, right?
But post plus plus and it would be okay.
Pause plus plus will do what we want it to do. Plus plus pause will not. It'll increment first. When the plus plus comes first, it increments first and then resolves down to its value. My opinion is never inline that. I want it to be the position pause, and then I want pause to be bigger than it used to be. Whether I say pause plus plus or whether I say plus plus pause, same thing there. I can say pause plus equals 1, whatever makes me happy.
Okay, that makes sense.
Right. You will never screw up if you do it this way. If you try to get fancy and start embedding things inside of that there,
Okay.
and you're not 100% confident in what you're doing, don't do it. Nobody cares about your fancy code that doesn't work. Make sense?
Yes.
Right. Now, you all believe that I know exactly how this works, right? I don't. I would never write pause plus plus or plus plus pause in there. I always write it the way you see me writing it here. Who cares about the extra line? Who cares? Now, why do you think that is? With 100% confidence, I absolutely know how that works. I know how to implement that. I write programming languages for a living. I can write that. Why do I not take advantage of that? What do you think?
It's just not a good habit to do that.
Oh, why not? If you're me, why do you think I don't do that?
Other people will not be able to.
There are some chances that you can mess up over there.
Oh, I never mess up.
It's going to be hard to for someone to read or someone to understand what exactly.
I'm very often coding for an audience. Is it in my best interest to make my code as easy to understand as possible? It's not just for my eyes, right? It's for other people's eyes too. None of you are impressed if I start making this gigantic line that's impossible to read. You'd rather have it spelled out so you're like, oh, that makes sense. I know there's no ambiguity to that, right? I encourage you to do the same thing. You may not be the only person ever looking at your code. Somebody else might be. Make it easy to understand. Comment stuff when it makes sense. Make sense? All right. So I would usually probably write pause plus plus for no good reason. Just that's what I usually write. All right, so this is going to go through, and every single time we call st.next token, it actually removes the token from the tokenizer. So the tokenizer keeps getting one smaller, one smaller, one smaller, one smaller. That's why we have it in a loop that says keep going as long as there's more tokens. That makes some sense? All right. Now, this is going to give me a token, but that token might have some spaces on it. Now it doesn't. I'll just trim the tokens as I'm taking them out. So when all is said and done, when I get to this line right here, inputs is filled with all of my tokens with spaces trimmed. 2 M's, 4 M's, that was that. All right, we're good. That make sense? All right, let's prove that to ourselves quickly, and then we'll take a short break. So we're kind of at our, now we are at a good stopping point, right? Spaces removed. All right. So what I'm going to go ahead and do is I'm going to give myself a getter for these inputs. Actually, let me do this. I'm going to just make a public method here. Public, now let's call it get input string. So get inputs as string. And this guy's going to return a string. I'm basically going to have this guy that's going to convert my array into a string. That way I can put it on that label just to show us. That way we don't have to go and hunt for it in the console. Because looking for stuff on Android's output console is a little bit quirky. Have you seen it? Have you done stuff at Android's output console already? Like, have you? Well, let's just do it then. It'll take us less time. I'll show you how it works. All right, so I'm going to go ahead and I'm just going to say, well, let's still write the function because we're going to possibly need it later. Private string inputs to string. And then we're going to go ahead and say string result is equal to the empty string. For int I is equal to 0, I is less than this dot inputs dot length, I plus plus. And then we'll go ahead and we're going to say if result dot length is equal to 0, then result is equal to this dot inputs at bucket I, else results plus equals, we'll put a little arrow guy in there. I keep saying results, don't I? Result plus equals arrow guy concatenated with this dot inputs at bucket I. And then we'll return result. All right, so this will take the contents of my inputs array, turn it into a pretty string that has, token plus, a little arrow, token, little arrow, token, little arrow. That way it displays on our screen nicely. So then down here, what I'll do is I'll say system.out.println this dot inputs to string. So I'll go ahead and print that out to the screen. Okay? And I'll show you the challenge that we will sometimes run into. All right, so this is called process string here. And I'll leave the remove extra spaces in there. We're not going to use it. But so what we're going to do is we're going to read in that string from our text box. We'll then use that string to create a new instance of shunting yard. And then we'll have that instance, then we're going to have that instance do this dot process string. So we'll have that instance will go ahead and automatically process the string for us. And as part of that, when it processes the string, it's going to go and get all of our tokens and then ultimately print this out to the screen. Not to our Android device screen, but to the console, like a log file thing. Okay? So let's go back into main. When our process button was clicked, we want to go ahead and get the value that's currently inside of input ET and create our shunting yard. SY is equal to a new shunting yard. And we'll build this guy using this dot input ET dot get text dot toString. That'll give us the string version of what's in there, because shunting yard requires a string to build it. And as part of that constructor here, we will set the string that's passed in to that guy's input string, and then we'll process that string, proving that we were able to tokenize the pieces out of it. Make sense? All right. So we know that the process string function that we wrote here, that guy at the very end will actually display something out to the console. Okay? So let's go ahead and run this puppy. And then we'll test it with some of our different inputs that use some of our different symbols that we allow, and we'll have some different spaces in there as well. Okay, so let's do 123 plus 14 times 2. So we'll do no spaces first. So we expect to have a 123 followed by an arrow, followed by a plus, followed by an arrow, followed by a 14, followed by an arrow, followed by a times, followed by an arrow, followed by a 2. Okay, so we'll do process. Come down here to the run. Oh, it didn't actually start. It didn't start the thing over. That's my process button. Okay, let's kill the application and relaunch it. It did the old version of the code. 123 plus 7 times 2. Still doing the old version.
Maybe build it and then stop it, build it.
Yeah, but killing it should have done that. It's clean project. This whole thing is just buggy. Rebuild project. Oh, actually, it maybe was working because I do still have it setting that. So let's not set the text. Oh, actually, I was breaking it. I was setting input ET equal to process click, so I was replacing all the text that I was trying to read in. I didn't have my 123 plus stuff anymore. Yeah, so that would be problematic. So yeah, let's remove that line. Yeah, I was just being stupid. I was testing you, and you all failed. That's what happened. All right, 123 plus 8 times 2. Now we'll do process. Nothing should change up there. Go to run. Here's my output. 123 arrow plus arrow 8 arrow times arrow 2. Looks like our tokens. Now let's go in and let's doctor this up a little bit. We'll put some spaces there, some spaces out in front. Then let's do a minus, space, 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 parenthesis, space 21 to the third power, close parenthesis, something like that. Process that. So token, 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 minus. Why did it get a space? Did I write this funny? The spaces were not legitimate. Oh, because since this is following a minus sign, this minus sign separates the two from a space. Does that make sense? There's a we have 2 tokens right next to each other here. So because of that, you will sometimes get a space here. You know, if we happen to write it without that space, well, actually, notice I had 3 spaces in there, but I only had 1 space as my output, so I trimmed the 1 space. So we will have to take that into consideration. We'll have to omit space tokens and just move past them. So it looks like it's doing what it's supposed to do. We just need to be a little careful about that situation, where one of our tokens is actually a space. In fact, actually, we can probably, let's just fix that real quick at the we'll set temp equal to that. Then we'll say if temp I actually think it would be the empty string dot length is not equal to 0. Then we'll say this dot, we're still going to have the, we have to handle it on the back end because we're building our string array to be big enough to hold all the tokens. So we might have a space token in there, so we'll just omit it when we're doing the shunting yard algorithm. All right, make some sense? All right, so let's take about 10 minutes. Is that good? So go take a quick break, come back, and we'll keep trucking with this, and I'll get this first recording going.